Guys, good morning. Happy Friday, everyone. We made it through week 4. Congratulations. Jason C., make sure you have your quote of the week ready for next week. And everyone, please fact check him, please, or make sure it's good. I'm sure you'll choose a good one, though. Okay, so I received a lot of questions from you guys about the just checking part from Thursday's notes. So I want to go over that step by step. Sorry, I rushed through it. Okay, so the first one, you have your textbooks open to page 28. So please pause the video and get there, because the wording is really, really important. So the first question said, what percent of females are brown-eyed? Okay, so the question is, this is going to be a conditional with the line. So probability of something given something. Okay, so is it going to be brown eyes, brown given female, or is it going to be female given brown? So let's read the question. What percent of females, so we're only looking at females. Sorry boys, we don't care about the males here. So of the females, what percent of them are brown eyed? Okay, so we're pretty much going to disregard the male row, and just of the females, brown would be the 16. So it'd be 16 over total of 32. Okay, so this should come out to exactly 50%. Got that? Pause the video, please, if you need more time to think about it. Really understand this, okay? 2 is pretty much the opposite. What percent of brown-eyed students? So the probability of something given something. So this time, of the browns, what percent are female? So we're gonna pretty much cover up everything else. Like, you're just gonna look at that right there, okay? So we have 36 total browns, and of them, how many are female? Would be 16. Okay, so that would be 44.4, sorry about decimal percent. Okay. Number 3, it's saying what percent of students are brown-eyed females? So when we say students, we're talking about all of these students right here. So total is 64. So probability you are brown and female. Probability of brown and female. Okay, so notice the difference of these 3 right here. So there are a total of 64 students, and brown and female would be 16 right here. So that comes out to a nice, easy 25%. Okay? All right. So number 4 is the distribution of eye color. Okay, so we're looking at the total of blues, the total of browns, the total of greens compared to the total. Okay. So you're pretty much going to cover up everything here and just focus on the total row. So the probability of blue, the probability of brown, and the probability of green, hazel, and other. Okay? So total for blue. So all of these are going to be over 64, because that's the total. So out of 64, how many are blue? How many total students? So it'd be 10. Okay, we're not disseminating between males and females. We just want the total. So 10 out of 64. And then brown would be 36 out of 64. And then green would be 18 out of 64. So this would come out to 15.63. If any of these numbers are wrong, please talk it over with your classmates. Or if you have any questions about each of these, talk it over with your classmates, because it is possible that I made a mistake. I'm under some pretty heavy medication right now. So My wife told me that today before the surgery, I sang God Bless America to the nurses. So that tells you what kind of state of mind I'm at. Anyways, brown. So this is 56.25. And then this one right here, we come out to 28.13. Okay, please pause the video, digest this stuff, okay? All right, we're gonna move on to number 5. That's a 5 right there. That's 5. Oh no, I kicked the stand. Come back. Oh, good enough. 5 says, what's the conditional distribution of eye color for the males? So that tells you immediately we only care about the males here, all right? Males, it's your turn now. So the probability of being blue, given that you're male, the probability of brown, given that you're male, and the probability of green, given that you're male. Go and take a pause and figure those out right now. How many total males do we have? We have a total of 32, so all these are going to be something out of 32. So how many blue males? We have 6. How many browns? We have 20. Oh, that seems like a high percentage. And 6. I wonder if being male gives you a higher likelihood of being brown-eyed. I don't know. So this comes out to 18.75%. Brown, given that you're male, what's the probability you have brown eyes? That would be 62.50. Okay. Given that you're a male, what's the percentage of those that have green eyes? Would be 11.75. Like that, okay? That's number 5. All right. Let us take a look at number 6 now. Move this up. Okay. So number 6 has to do with number 7. So let's do number 6 and 7 kind of together. So number 6 is saying compare the percent who are female among blue-eyed students. All right, so take a pause right there, think about it. Is it the probability of females given that they are blue-eyed, or is it the probability of blue-eyed given that you are a female? So this would be, what's the probability of you being a female given that you are blue-eyed? And then we want to compare that to the percent of all students who are female. So simply percent probability of female. Okay. So if these two values, whatever we come up with here, whatever this value comes out to, if those are equal, then we say that yes, they are independent. Look right above where it talks about. Right above the just checking, read this section right here. Okay? Again, we'll get heavier into this later on, but right now we're just introducing it. So if these two values are equal, then we say that they're independent. Now, someone sent a great message to me asking, do they have to be exactly equal? If one is 50%, the other one's 51%, yeah, we just say they're equal. If one's 25 and the other one's 27, yeah, that's close enough, okay? Now, if you tell me on a test that this is 30% and this is 98%, and you say, yeah, they're close enough, I'd question that, okay? No, I wouldn't question that. I would mark it wrong. So the probability of being a female, given that you're blue-eyed, so this would just be 4 out of 10, which would be a nice round 40%. And what's the probability of you being a female total? This would just be 32 out of 64, which would be a nice round 50%. So are they close? No, no, no. Are they the same? This is not close. Okay? Now, someone's thinking, okay, what is the cutoff? If they're 2% away, do we say they're the same? If they're 3% away, difference, are they the same? You know, if they're like within 3, or like 2 or 3, you can make an argument that they're the same. Okay? If they're 10, definitely not. And on a test or quiz, I'll make it very obvious. They'll be really, really close, or really far apart. So we say no. We're comparing the two variables. Eye color and gender are not independent. Now, do not say eye color and gender are dependent. The opposite of not independent is not dependent. Okay, think about that. Think about that all weekend long. Okay? All right, guys. That's it.